Can you solve this math problem in less than a minute? We have x cubed minus 2x squared plus 0x minus 4 divided by x minus 3. This looks like such a monstrosity, and division is already the hardest out of the four operations in my opinion, so how can we solve this in literally a minute? Very easy way, and it's called synthetic division. But first of all, what is synthetic division? It's time to learn through a song. Synthetic division is an easy way to divide polynomials when one is x minus c. C has to be a constant numeral. The leading coefficient of x is always 1. Write C on the top left, write the coefficients of the dividend next to it on the right. Bring down the leading coefficient to the bottom row. The solution will soon be in sight. Multiply C by this value and place this value underneath the next coefficient. Add the values of the column together, multiply again, then repeat until done. Answer to the example that we just did in the song can be written as follows. So since the first in the polynomial is x squared and we have 1, this would be x because we always have one exponent less. So this is x, and since the power of this is 1, the power of this next item will then be 0. So the next one would just be minus a plus c. And then when we write the remainder, we'll just say plus c squared minus ca plus b, and then you put it over x minus c. This is our answer. Now let's go back to solving the problem from the beginning. We have x minus 3 and then x cubed minus 2x plus 0x minus 4. How do we know to use synthetic division? The first two lyrics of the song were, synthetic division is an easy way to divide a polynomial when 1 is x minus c. C has to be a constant numeral. In this case, it's 3. The leading coefficient of x is always 1. In this case, it is. So we can continue on. Now let's solve this in just 1 minute. So now we have to write c on one side and the leading coefficients of the polynomial on the other side, which is 1, minus 2, 0, and minus 4. The next thing we would do is to drag the first polynomial, the first coefficient down, multiply them both, and then carry the product over to the second column, and then we add them, and then we multiply 3 by that, and then we continue. Hold on, I made a mistake. It's not 1. It's supposed to be 3. Hold on, let me fix that really quickly. The next thing that we would do is just add again, and then keep going until the end. And the very last number that we have, if it's greater than 0 or just not equal to 0, then it is the remainder, which is 5. Now you're probably wondering, why does all of this work? Why does synthetic division exist? She solved another problem using both long division and synthetic division so that we can see the parallels between these two and why synthetic division works. I got inspiration from the Khan Academy video on this topic, which I will link in the description. So when we have x minus 5 and x squared minus 2x minus 2, you have to see what you can multiply x minus 5 by to get something close to x squared minus 2x. The logical thing to do would be just to multiply this whole thing by x. So you would get x squared minus 5x. And as a result, you have an x on the top here. But what we can also see is we have a 1 right here, which corresponds to the x right here. And the difference is we're easily able to drag this 1 over, but here we actually had to do the work. With synthetic division, we're making the assumption that what we're dealing with here, the x always has a leading coefficient of 1. Because if x has a leading coefficient of 1, then you would only have to multiply by x times the leading coefficient of whatever this is. So if this were 3x squared, then you would multiply this by 3x. And then, as a result, this would be a 3, and you would just drag the 3 down. The next thing we do here is we subtract. So when you subtract minus 5x, it becomes positive. So you get 3x minus 2. You multiply x by 3 to get 3x, which gives you this. you subtract a negative again to get a positive, and you get 13, which is our remainder, which is the same thing that happens here when we utilize the process of synthetic division. But the difference is this looks a lot cleaner, which is why I recommend to use this when you are dividing by a polynomial which has a leading coefficient of 1 for x and a constant c. One thing we can notice though is what happens when you plug in 5 into this equation right here. So you get 5 squared is 25, and then you subtract 10, which means you get 15 minus 2, and you get 13, which means the remainder is what you get when you plug this into this, which is why synthetic division is a way to solve for your zeros of a polynomial. Now I'll end the video with why does the remainder actually equal the function value? When we perform synthetic division but instead replace all of the numbers with letters, we solve this and then we find out that the remainder of this function is just equal to c squared minus ac plus b, which is equivalent to if you plug c into the function. So there's your proof.